Let's do a few examples now where we're actually writing the equation of the function given a few of the different transformations. So write the equation of the function with the shape of f of x equals the square root of x with a vertical shift down 3 units, a horizontal shift 2 units right, and a reflection in the y-axis. So in this case, what we're going to be doing is trying to identify what all of those constants, a, b, c, and d, are going to be so that we can apply them to our particular function. So again, make note of that general form. We have c times the function f of a times the quantity x minus b plus d. Now, in this particular case, because we want this to have the shape of a square root function, our form should look like g of x is equal to c times the square root of a times the quantity x minus b plus d. Notice all we did is we replaced f with our parent. F is equal to the square root of all of that. Yes, so we took f, and instead of f, we put in a square root. So let's see if we can't identify our constants a, b, c, and d. All right, so let's start off with our constant c. We'll just go in order from left to right here. All right, c controls our vertical stretches and vertical shrinks and also gives us our x-axis reflections. Well, do we have any of that going on? No. Okay, no vertical stretch, no vertical shrink, no x-axis reflection. If that is the case, that means c is just going to be 1. And again, 1 is the standard. Notice you could say that technically there's a 1 in front of this parent function, 1 times the square root of x. All right, so we have no transformations. That constant multiple is going to be a 1. All right, next, let's look at the constant a. The constant multiple a inside of the parent function controls our horizontal stretches and horizontal shrinks, as well as reflections in the y-axis. Well, I don't have any horizontal scalings, but I do have a y-axis reflection. And so if we have a y-axis reflection, that means that that a value is going to be a negative 1. Okay, a is equal to negative 1. The negative is what gives us our reflection in the y-axis. Because the next part of it is a 1, nothing else is going to be scaled horizontally. A horizontal shift. B controls our horizontal shift. In this case, we want a horizontal shift 2 units to the right. If we want to shift the graph 2 units to the right, that means that we want B to equal 2. And finally, we have a vertical shift down 3 units. Well, that is controlled by our constant d. And because it is a shift down 3 units, we want d to be negative 3. Once we identify all of those constants, all we have to do is plug them in. G of x is equal to, notice c is just a 1 in front of here, times the square root of negative 1 times x minus 2 minus 3. Now, that's a good final answer, and I would probably give you full credit for that on a test or quiz. All right, one thing that we could do to make it look a little bit better is just distribute this negative through. This would be g of x is equal to the square root of negative x plus 2 minus 3. All right, one more example here. Write the equation of the function with the shape of f of x is equal to x squared with a vertical stretch by 3, a horizontal, throw a t in there, horizontal shrink by a factor of 2, a reflection in the y-axis, a horizontal shift 3 units left, and a vertical shift up 5 units. Wow, that's a lot going on. Let's see if we can do it. Note the general form, y equals c times f of a parentheses x minus b plus d. Well, again, what type of function are we going to be dealing with here? A quadratic. Therefore, we can just replace f with x squared. So this is going to be g of x is equal to c times the quantity a times x minus b, quantity squared, plus d. All right, so let's figure out what our constants a, b, c, and d are going to be. Again, c is vertical scalings and reflections in the x-axis. Do I have any vertical scalings? Well, we have a vertical stretch by a factor of 3. Do I have an x-axis reflection? No. vertical stretch by a factor of 3, no x-axis reflection. Well, that means our c constant is going to be 3. Now, what else do we have? We have our constant multiple a. That controls our horizontal scalings and reflections in the y-axis. Notice we have a horizontal shrink by a factor of 2. A horizontal shrink by a factor of 2, that means all our x-coordinates are going to get divided by 2. And we have a reflection in the y-axis. Now, the horizontal shrink part, that is going to mean that a is going to be 2, but because we also have this y-axis reflection, that means a has to be negative as well. A is equal to negative 2 in order to make both of these statements true. All right, our next constant, b, that's our horizontal shift. Here we have a horizontal shift 3 units to the left. That means b is going to be negative 3. And finally, we have a vertical shift up 5 units. The constant d controls our vertical shifts, therefore d is going to be equal to 5. Now that we have each one of those constants labeled, plug them in. G of x is equal to 3 times negative 2 parentheses x minus a negative 3 close parentheses squared plus 5. And we can do out a little bit of algebra to make that look a little bit nicer. Notice that subtracting a negative 3 becomes a plus 3. And if I multiply that by negative 2, that gives me a negative 2x minus a 6 inside of my parentheses, giving me 3 times the quantity, negative 2x minus 6 squared, plus 5 for my final answer. That function right there will have all of the transformations that we have stated up above. All right, there you have it, writing our equations of our functions.